In this video, we will be describing about direct memory access. We members are Keur Barde, Ritika Bari, Mansi Barse, myself Shreya Barsude, Ove Baritakki, Shreya Barvi. Our contents are so now here we will starting with our content.
Direct memory access is a feature of computerized system that allows certain hardware subsystem to access main system memory independently of the central processing unit. Direct memory access is a method that allows an IO device to send receive data directly to or from the main memory by passing the CPU to speed up memory operations. The process is managed by a chip known as DMA controller. What is DMA? The Direct Memory Access I/O technique provides direct access to the memory while the microprocessor is temporarily disabled. I/O devices are connected to system bus via a special interference circuit known as DMA controller. In DMA, both CPU and DMA controller have access to main memory via a shared system bus having data address line control lines. It is sometimes referred to as a channel. In an alternate configuration, the DMA controller may be incorporated directly into the I/O device. A DMA controller temporarily borrows the address bus, data bus, and control bus from the microprocessor and transfers the data bytes directly between an I/O port and a series of memory locations. The DMA controller performs a function that would normally be carried out by the processor when accessing the main memory.
So, why DMA? When data is transferred between the devices and the main memory, the processor has to be involved in the data transfer process, which can cause delays in the processing of other tasks. This is because the processor has to wait for the data transfer to complete before it can move on to the next task. DMA helps to overcome this bottleneck by allowing data to be transferred between the device and memory without involving the processor. DMA uses dedicated DMA controller to manage the data transfer process, which enables the data to be moved between the devices and memory at much higher speeds and with less CPU utilization. By offloading the data transfer task from the CPU, DMA can free up CPU resources, reduce latency, and improve the overall performance of the system. Then with versus without DMA. So without DMA, the CPU is using programmed input output. It is typically fully occupied for the entire duration of the read or write operation and is unable to perform other works on tasks. And with DMA, the CPU initiates the transfer, does other operations while transfer is in the process and receives an interrupt from the DMA controller when the operation is done. So hence DMA is important as it keeps the CPU idle and helps the CPU to manage other tasks while it is still transferring the data.
So how the DMA IO technique works is it provides direct access to the memory while the microprocessor is temporarily disabled. A DMA controller temporarily borrows the address bus, data bus and the control bus from the microprocessor and transfers the data bytes directly between an IO port and a series of memory locations. So it cuts the microprocessor acting as a middleman between the IO port and the memory. The DMA transfer is also used to do high speed memory to memory transfers. Two control signals are used to request and acknowledge a DMA transfer in the microprocessor based system.
Data transfer with DMA controller. During a block input byte transfer, the following sequence occurs as the data is being sent from the interface to the memory. The sequence is as follows. The interface sends the DMA controller a request for DMA service. A bus request is made to hold the pin active high on the 8086 microprocessor and the controller gains control of the bus. A bus grant is returned to the DMA controller from the hold acknowledge HLDA pin active high on the 8086 microprocessor. The DMA controller presses contents on the address register on to the address bus. Then it is followed by the controller sending the interface a DNA acknowledgement which tells the interface to put data on the data bus. For an output, it signals the interface to latch the next data placed on the bus. The data bit is transferred to the memory location indicated by the address bus. The interface latches the data. The bus request is dropped, the hold pin goes low, and the controller relinquishes the bus. The bus grant for 8086 microprocessor is dropped and the HLDA pin goes low. The address register is incremented by 1 and the bit count is decremented by 1. If the byte count is non-zero, we should return to step 1, otherwise stop. Now we will see the sequence in a flowchart representation. So the flowchart is as follows. The DMA request is done, then DNA acknowledgement is done, then it goes to the address memory. Address memory, it transfers data. When the transfer is complete, it increments the address by 1 or it decrements the address by 1. And at the last, when the process is complete, we terminate the DMA. Thank you.
So our next topic is DMA controller options for data transfer. There are three DMA controller options. First is cycle steal, second is burst steal, and the third is the hidden DMA. So we will starting with the first one, cycle steal. A read or write signal is generated by the DMAC and the IO device either generates or latches the data. The DMAC effectively steals cycles from the processor in order to transfer the byte, so single byte transfer is also known as cycle stealing. The next one is the burst steal. To achieve block transfers, some DMACs incorporate an automatic sequencing of the value presented on the address bus. A register is used as a byte count, being decremented for each byte transfer, and upon the byte count reaching 0, the DMAC will release the bus. When the DMAC operates in burst mode, the CPU is halted for the duration of the data transfer. Next is hidden DMA. It is possible to perform hidden DMA, which is transparent to the normal operation of the CPU. In other words, the bus is grabbed by the DMAC when the processor is not using it. The DMAC monitors the execution of the processor, and when it recognizes the processor executing an instruction which has sufficient empty clock cycles to perform a byte transfer, it waits till the processor is decoding the opcode, then grabs the bus during this time. The processor is not slowed down but continues processing normally. Naturally, the data transfer by the DMAC must be completed before the processor starts.
Some uses of it are it can be used in data transfers between the hard drive and the memory during disk operations such as read or write. It can be used in network data transfers between the network card and the memory during network communication such as uploading or downloading something from the internet. It can be also used in audio and video data transfers between the sound or video cards and memory during the multimedia playback or recording. These all are the peripheral devices, and through DMA they can directly access the memory without the intervention or without needing any help from the microprocessor.
There are five types of DMA data transfer modes. First is the single transfer mode. In single transfer mode, the device is programmed to make one transfer only. In single mode only, one byte is transferred per request. Second is the block transfer mode. Once the DMA controller is granted access to the system bus by the CPU, it transfers all bytes of data in the data block. This mode is called block transfer mode. Once a block transfer is started, it runs until the transfer count reaches 0. Third is the demand transfer mode. Demand mode DMA allows PC hardware to transfer many bytes of data via a DMA channel with only a single programming of the DMA controller. Fourth is the cascade mode. This mode is used to cascade additional DMA controllers. Actual bus signals is executed by a cascaded chip. Fifth is the memory to memory transfer. To perform the transfer of the block of data from one set of memory address to another one, this mode is used. This means data can be transferred from one memory device to another memory device. So, the advantages and disadvantages are given below. Advantages are DMA allows a peripheral device to read from or write to memory without getting through the CPU. DMA allows for faster processing since the processor can be working on something else while the peripheral can be populating memory. Disadvantages are the DMA transfer requires a DMA controller to carry out the operation, hence cost of the system increases. Second is the cache coherence problems.
And this was for direct memory access. Hope you find it helpful. Thank you. Do like, comment, and share.